In a thermodynamic process, the pressure of a fixed mass of gas is changed in such a manner that gas released 30 joule of heat and 18 of work done. Initial value they given us 60 joule and final energy will be. So gas released 30 joule of heat. That is, heat is removed from the system. So heat is removed from the system as, what is the given value? 30 joule. Now it is removed, heat is removed from the system, so negative sign. Now next they given us work done on the gas is 18 joule. Note that work done on the gas is equal to, that is negative sign. Work done by the gas is positive sign. So here they given on the gas. So it is negative sign. Now given initial energy as Ui is equal to 60 joule. We need to find the final energy. According to the law of thermodynamics, first law of thermodynamics, heat released is equal to del U plus work done. Now this can be written as heat released, they given the value as 30 joule, and this is the change in energy, can be written as final minus initial. Work done, they given the work done as minus 18 joule. Now 30 plus 18 is equal to UF minus, here what is the initial value? 60 joule. Now UF is equal to minus 30 plus 18 plus 60 is equal to, UF is equal to 48 joule. So the final energy will be 48 joule. The value of current through 5 ohm resistor of a given circuit is, our aim is to calculate in this 5 ohm resistor how much amount of current is flowing. Now this is the current direction. I am going to take this as an I amount of current is flowing in this direction. Now this is the same path, so this amount of I amount of current flows in 4 ohm also. So here is also I amount of current is flowing. Now there is a 2 path take place here. So first path, this path I am going to take this path as an I1. Okay. So what is this path? This path represent now I minus I1. Now according to the Kirchhoff's second law, now I am going to take this first, this loop. Okay. Now I am going to write the equation for this loop. Here the current I amount of I1 amount of current is flowing in this direction, 5 ohm. So note that current, if the current and path is in same direction, here the current and path direction is like this. For this loop the path direction is like this. So if the current and path direction is in same direction, we will write negative sign. The sign is here negative. Okay. So here the current and path is in same direction. So I am going to write the equation as minus 5I1. Here we are having 5 ohm. So current is flowing in this direction now. Path is also same. So minus 5I1. Now one amount of current is flowing in this direction, positive to negative. So here note that when it is going from positive to negative, we will represent that negative sign. Sign is negative. Sign is negative. So 5, here 3 volt. 3 volt amount of current is flowing from positive to negative. So minus 3, and here now this current I1 current is flowing in this direction. Now the path and the current direction are in opposite direction. The path here is the current direction and this is the path direction. So it is in opposite direction. So path and current is opposite direction means positive sign. So I am going to represent the positive sign plus, here we are having 8 ohm. So 8 I minus I1. Now solve this equation. Minus 5I1. Here 8I minus 8I1 is equal to, taking this minus 3 in this side, so plus 3 plus 3. Now this can be written as 8I minus 13I1 is equal to 3. Keep this as equation number 1. Okay. Now this loop I completed. Now we are going to go for this loop. Now how much amount of current is flowing in this loop we are going to see. We need to find I amount of current is flowing in the path direction 4 ohm, for 4 ohm same path direction. So current and path is in same direction now. So we want to represent the sign as a negative sign. So here minus 4I amount of current is flowing. Now here also this loop I am taking this loop. The current is flowing in this direction only. The path is also in this direction only. So path and current is in same direction. So I am going to take same direction means path and current in same direction. This is same direction. Same direction means negative sign. So negative sign minus of 8, minus of 8, I minus I1. And here now the current is flowing like this in this direction. It is coming here. This is I1 amount of current is I amount of current is flowing. Now here it is in negative to positive. So negative to positive means the sign is here positive sign. So positive sign is positive 5 is equal to 0. Now this can be written as minus 4I minus 8I plus 8I1 is equal to minus 5. Okay. Now minus 12I plus 8I1 is equal to minus 5. Okay. Now I am going to multiply with negative sign. So 12I minus 8I1 is equal to 5. Now keep this as equation number 2. Now solve the equation. Our aim is to calculate now how much amount of current is flowing here. So we need to find that is I1 amount of current. What is the I1 amount of current? So solve this equation. Multiply equation 1 into 12 and equation 12 into 8. Okay. So equation 1 into 12, multiply this one. We will get here 96I minus 156 I1 is equal to 36. And multiply now equation 2 into 8. 96I minus 64 I1 is equal to 40. Now change the sign. So this get cancelled and this can be written as now minus 4 and this is of 2 and here 92. This is negative sign. I1. Now I1 minus 92 I1 is equal to minus 4. So I1 is equal to 4 by 92 and I1 is equal to 1 by 23. Current we will represent in ampere, so I1 is equal to 1 by 23 ampere. So the correct option is here 1 by 23 ampere. A particle of mass 1 kg is executing simple harmonic motion with an amplitude 1 and the time period is pi second. Calculate the kinetic energy of a particle at a moment when a displacement is, they given the displacement value is 0.8 meter from its mean position. Given, what is the given value? Mass is equal to 1 kg and amplitude is equal to 1 amplitude. Time period is equal to pi second. Calculate the kinetic energy. We need to calculate the kinetic energy of a particle when the displacement, so displacement they given us 0.8 meter. Now our aim is to find the kinetic energy of a particle of the moment. Now we know that the kinetic energy is equal to half mv square. In the simple harmonic motion we will write the velocity as omega root of a square minus y square. Now you substitute these values here. Now the kinetic energy becomes 1 by 2 m omega square a square minus y square. Now the kinetic energy is equal to half m, the mass, they given the value of mass as 1, omega is the angular frequency. The angular frequency is equal to, omega is equal to 2 pi f. F is nothing but the frequency f is nothing but 1 by t, and omega we can write as 2 pi by t. Now they given the value of t as pi second. So pi get cancelled. Now omega angular frequency can be written as 2 radian per second. So here the omega angular frequency is 2 square, amplitude is 1, so 1 minus displacement is 0.8 the whole square. Now kinetic energy is equal to half into 4, 0.8 the whole square is 0.64. Now this get cancelled. Now the kinetic energy, on substituting this you will get the kinetic energy as 0.72 joule. So the option is 0.72 joule.
The correct thermodynamic conditions for the spontaneous reaction at high temperature. They are asking spontaneous reaction at high temperature. In option 1, here they are giving del H negative and del S value is positive. This condition is spontaneous at all temperature, not high temperature. So this is wrong. In option 2, here del H value is negative and del S value is negative. Here the reaction is spontaneous at low temperature, and not spontaneous at high temperature. In option 3, the del H value is positive and del S value is negative. Here the reaction is non-spontaneous at all temperature. In fourth option, the del H value is positive and del S value is negative. Del S value is also positive. In this condition, the reaction is spontaneous at high temperature. Here they are asking spontaneous reaction at high temperature. Here among the four, the option 4 is a spontaneous at high temperature. Role of hydrogen peroxide in the following reaction is, here they are giving ozone reacted with hydrogen peroxide. Ozone which is reacted with hydrogen peroxide, which gives a water and oxygen. Here this ozone is reduced to oxygen. So the peroxide in this reaction, which is acting as a reducing agent, because it reduced the ozone to oxygen. So the correct answer is option A, reducing agent. The number of neutrons present in the radioactive isotope of hydrogen. First we have to know what are all the isotopes of hydrogen. One is protium, that is H1H, and second one is deuterium, and third one is tritium. Here this is the radioactive isotope. Here they are asking number of neutrons present in the radioactive isotope. This number of neutrons is calculated from subtraction of atomic number from mass number. Mass number minus atomic number. Here what is the mass number? That is 3. Atomic number is 1. So the total number of neutrons present in this isotope is 2. So the option 2 is correct.
In Michelson and Stark experiment, after an hour, what percentage of DNA would be light, heavy and hybrid respectively? To find out the percentage, we should be aware of the experiment carried out by Michelson and Stark, isn't it? It represents semi-conservative model of replication, isn't it? So from this experiment they used E. coli. So one single life cycle of E. coli goes for 20 minutes. In question what they have asked is for 1 hour, so which is 60 minutes, and in 0th minute we will have one parental DNA, and during the first generation, that is in the first 20 minutes, we will get this parental DNA will be put in the media which is enriched with N14, isn't it? N14 is considered as light and N15 as heavy. So when they undergo semi-conservative replication, we in F1, that is first generation, we will get 2 hybrids. So we get 2 hybrid helix which is 100% hybrid, and in the F2 generation, 1 hybrid will give rise to 1 hybrid and 1 light chain. So the product will be 2 hybrid and 2 light chains at the end of second generation, which is at the 40th minute. Okay. So yeah, 50% will be hybrid and 50% will be light. And now 1 hybrid will give rise to 1 hybrid and light chain, and light chain will give rise to only light chain, and here again the light chain will give rise to 2 light chains, and the hybrid will give rise to 1 hybrid and 1 light chain, isn't it? Now when we count, we get 6 light chains and 2 hybrids. So at the end of third generation, that is at the end of 1 hour, this is what is asked in question. At the end of 1 hour, we will get 2 hybrids and 6 light chain, and the percentage would be 25% hybrid and 75% light. But in question they have asked the ratio as light, heavy and hybrid. So the answer would be for hybrid it is 25%. There is no heavy chain, and for light it will be 75%. So we have got the answer. In a vector, an antibiotic resistance gene usually helps in the selection of. So when do we use antibiotic resistance gene? It is usually present in the vector. And why do we need antibiotic resistance gene? Just to screen the transformed cells. For example, if you are making a recombinant cell, okay, your cell has an antibiotic, say tetracycline, okay. For example, your vector possesses tetracycline resistance gene, and when after the transformation process, when you grow it in a media containing the antibiotic tetracycline, all the transformed cells, that is all the cells which have uptaken the recombinant DNA will be able to grow in the tetracycline present medium. So the antibiotic resistant gene is helpful for screening transformed cell. Coming to recombinant cell, what are recombinant cells? Recombinant cells are those whose DNA has been already manipulated. Competent cells, they are ready to uptake a new DNA. So they are called as competent cell. And fourth option is all the above. So that is not the option. The answer is transformed cells. Choose the semi-dwarf varieties of rice which is developed in India. So there are a lot of semi-dwarf varieties of rice, but in question they have specifically asked which is developed in India. Now, considering the given options, the Sonalika and Kalyana Sona are wheat, okay. In the question they have asked about rice that is developed in India. So we will reject this answer. And coming to IR8 and Taichung Native 1, they are semi-dwarf varieties of rice, but they are produced in IRRI, Philippines. So this is also not our answer. Coming to Jaya and Ratna, they are semi-dwarf varieties of rice which is produced in India. So they are origin of India. And Atlas 66 and Himgiri are wheat varieties, whereas Atlas 66 is biofortified wheat and Himgiri is disease resistant variety of wheat.
Match the following column 1 with column 2. So we have to match column 1 and column 2. In column 1 we have albumin, globulin and fibrinogen, that is we have plasma proteins, and in column 2 we have their functions. So we have to match the plasma proteins with their functions. First, albumin. Albumin helps to maintain the osmotic balance. So option 1 matches with option 3. Globulin. Globulin helps in defense mechanisms and transport mechanism. So here they have given defense in 1. So 2 goes for 1. And fibrinogen. Fibrinogen is involved in clotting. So let's see. The option is for 1 it is 3. For 2 it is 1. For 3 it is 2. So the correct answer is option 4. Coming to next slide. Here we all know that blood is divided into plasma and formed elements. The plasma contributes about 55% of the total volume of blood. So the plasma contributes 55% and formed elements contribute 45%. Among the 55%, about 6 to 8% is contributed by the plasma proteins. The plasma proteins are albumin, globulin, fibrinogen and other small proteins are also present. The major proteins are albumin, globulin, fibrinogen. Albumin helps in maintaining the osmotic pressure of plasma. Globulins and they are nothing but the antibodies which are involved in defense and in transport functions. Fibrinogens, they are involved in clotting mechanism. So, for this question the answer is option 4. In which of the following regions the muscles are under voluntary control of nervous system? So, I am reading it again. In which of the following regions the muscles are under voluntary control of the nervous system? So, they have given regions of a body. So, we have to find out which of the muscles of which of the regions are under voluntary control of nervous system. For lower limb has skeletal muscles. We all know that lower limb has skeletal muscles. Heart has cardiac muscles. Intestine has smooth muscles. And reproductive tract also has smooth muscles. So, we all know muscles are of 3 types: skeletal muscles, cardiac muscles and smooth muscles, among which the skeletal muscles are under voluntary control of nervous system and cardiac and smooth muscles are involuntary. So, the lower limb has skeletal muscles. So, the correct option will be option 1, lower limb, okay, which is under voluntary control of nervous system. Coming to the next slide. So, these are the types of muscles: skeletal muscle, cardiac muscle and smooth muscle. Skeletal muscle, which is associated with the skeletal system of the body, and cardiac muscles are found in heart and smooth muscle in GI tract, gastrointestinal tract, reproductive tract, eye and blood vessels. The skeletal muscles are striated, cardiac muscles are striated and branched, and smooth muscle will have no striations. So, skeletal muscles are voluntary, whereas the cardiac and the smooth muscles are involuntary. So, for this question the correct option will be option 1, lower limb. The approximate weight of A given in the diagram is. So, we have to find out the weight of the organ A given in the diagram. So, A is nothing but kidney. So, they are asking the weight of kidney. The correct answer will be option 2, 120 to 170 gram. In measurements of kidney, we have to remember certain measurements, certain values. For exam, they are the length, width, thickness and weight of the kidneys. So, the length is 10 to 12 centimeter. The width is 5 to 6 centimeters. The thickness is 2 to 3 centimeters and weight is 120 to 170 grams. So, you have to memorize this and remember these values. Along with that, I have given an additional point which you have to remember: the weight of liver. Liver is the second largest organ and the weight of liver is 1.2 to 1.5 kg. So, remember these numerical values. For this question, the option will be option 2, 120 to 170 grams.